Vocabulary of the day: systems of linear equations, defined as two or more linear equations with the same variable. As I've said before, for our purposes, we will be only working with two. We are reviewing 6.1 and 6.2 in your book. It covers pages 369 to page 383. Our goal for today is to solve a system or systems of linear equations by graphing and substitution. We're going to start with reviewing 6.1. 6.1 was graphing. So as we've talked before, our first step is to get them into y equals mx plus b so that we can identify the slope and the y-intercept. So our first equation, negative 5x plus y equals 0. We need to add 5x to both sides. We end up with an equation of y equals 5x. From here, we can easily identify our slope as 5 over 1 and our y-intercept as 0. So we're going to plot some points with this equation first. Our first point is 0, 0. That's our y-intercept. Our slope says over 1 and up 1, 2, 3, 4, 5. Over 1, 1, 2, 3, 4, 5. So if you grab a ruler, I'm going to try and grab my straight line maker, and we connect these points as best we can with a straight line. Now, working on the second equation, we have 5x plus y equals 10. We subtract 5x from both sides. We end up with y equals negative 5x plus 10. Identifying our slope as negative 5 over 1, our y-intercept as 10. So our first point goes at x is 0, y is 10. My slope says over 1 and down 1, 2, 3, 4, 5. Over 1 and 1, 2, 3, 4, 5. If I grab my straight line maker once again, I'll try to use red here so we can see the two separate lines. Take my highlighter, we can see these 2 points intersect right here. The value of that point of intersection, my x value is 1, my y value 1, 2, 3, 4, 5. So the solution to this equation, x is 1, y is 5. We'll move to the next example. Again, we're still sticking with 6.1 to review. So the first step is to get our first equation, negative x plus 2y equals 3 into the correct form. We add x to both sides. We have 2y equals x plus 3. We need to find y, so we divide everything by 2. Y equals 1/2 x plus 3 halves. Identify my slope as 1 over 2, my y-intercept as 3 over 2, better known as 1 and 1/2. So looking at my graph, my first point is estimated to be 1 and 1/2. The slope is 1 over 2. That means over 2 and up 1, over 2 and up 1. Remembering that we could also go this way, 2 and 1. We're looking for a positive slope. We're going to make a line connecting these points and move to our second equation, 2x plus y equals 4. We subtract 2x from each side. Y equals negative 2x plus 4. My slope in this case is negative 2 over 1. My y-intercept is 4. So my first point, 1, 2, 3, 4. My slope is over 1 and down 2. Over 1 and down 2. Remembering I could also go this way, 1 and 2. Grabbing my straight line, I'm going to connect the points I just made. Using a highlighter, it appears they intersect right there. That value, x is 1, y is 2. So the solution to this system of linear equations is 1, 2. Okay, moving on to solving by substitution, which comes from section 6.2. I need one of my equations in x equals or y equals form. In this case, I have a choice. So what we're going to do is we're going to take this value and substitute it into this equation for y. I've told you to underline and circle. Underline what it is you're putting in and circle where you're putting it into your equation. So x equals 17 minus 4y. X equals 17 minus 4. And instead of y, we're going to put in x minus 2. X equals 17. We're going to distribute our negative 4 here and here. Negative 4 times x is negative 4x. Negative 4 times negative 2 is negative 8. We're going to look for our like items. This and this are our like items. So 17 and 8 would be 25 minus 4x. Looking again at like items, we have a negative 4x and an x. To get this negative 4x across the equals, I have to add it to both sides. So 1x plus 4x gives me 5x equals 25. Divide each side by 5, x equals 5. So I have a value for x. I need to find y. I can substitute it into either equation. I'm going to start with the second equation because it looks like the easiest. Instead of x, I'm going to put in 5. 5 minus 2 gives me 3. The answer, the point where these two linear equations intersect, the solution is 5, 3. Remember x, comma, y. And we'll look at one more example from 6.2. We have x equals 16 minus 4y. 3x plus 4y equals 8. So in this case, we're going to take this value and put it into the equation for x. 3x plus 4y equals 8. 3 instead of x, 16 minus 4y. Oops, sorry, my mistake. Let's correct here. That's why I write the original equation. Plus 4y equals 8. I want to be sure I include this full equation here. 3 times 16 would be 48. 3 times negative 4y, negative 12y, plus 4y equals 8. Looking for my like items here, I have two y's on the same side. So I'm going to leave my 48. Negative 12y plus 4y, negative 8y equals 8. Like items I have here and here. To get 48 to the other side, I subtract. So I'm left with negative 8y equals negative 40. Divide both sides by negative 8. Y equals 5. I have a value for y. I need to find x. I can put it into either equation. I am going to choose the first equation. 16 minus 4y. X equals 16 minus 4. And instead of y, I'm putting in 5. So x equals 16 minus 20. X equals negative 4. So the solution, the point where these two lines would intersect, negative 4, 5. Today's assignment is a worksheet. Please get started.